The two satellites that make up the Bepi Colombo mission to Mercury were presented to the media on Thursday. This joint European-Japanese venture has been in development for 2 decades, but should finally get to the launch pad next year. The two spacecraft will travel together to the baking world, but separate on arrival to conduct their own studies. Thursday's event was the last chance for journalists to view the full flight stack, as it is called, Europe's Mercury Planetary Orbiter (MPO), and Japan's Mercury Magnetospheric Orbiter (MMO) will shortly be unbolted from each other for some final individual testing, prior to shipment to the launch site in French Guiana. The double mission is due to get underway in the October of 2018. An Ariane rocket has been booked to carry all the equipment skyward. Everyone will have to be patient, however. It is going to take 7 years for the satellite duo to get to their destination. The gravity of the Sun pulls hard on any spacecraft traveling into the inner solar system, and Bepi will have to fire thrusters in the reverse direction to ensure it does not overshoot the target. Mercury is the least explored of the rocky planets, but not because it isn't interesting, said Professor Alvaro Jimenez Canet, the director of science at the European Space Agency. It's because it's difficult. It's difficult to get there. It's even more difficult to work there. Temperatures on the surface of the diminutive world go well above 400 C, hot enough to melt some metals, such as tin, zinc and lead. The MPO and MMO will be looking to extend and deepen the knowledge gained at Mercury by the U.S. Space Agency's recent Messenger mission. The American probe, which ceased operations in 2015, took some 270,000 images of the planet's surface and acquired 10 terabytes of other scientific measurements. It provided remarkable new insights on the composition and structure of the smallest terrestrial planet, and it made the amazing discovery that, despite those high temperatures, there are shadowed craters where it is still cold enough to support water ice. ESA and the Japanese Space Agency (JAXA) hope that the more advanced, higher-resolution technology on their satellites will be able to answer questions that Messenger could not. ESA's Bepi Colombo project scientist, Johannes Bankhoff, said, "We need to come up with new ideas. And for that reason we need to have good instrumentation and we need to do very close monitoring of the planet, and we can do that with our spacecraft that we're sending to Mercury." The key conundrum is why the planet contains an outsized iron core and only a thin veneer of silicate rocks. A favored theory before Messenger was that Mercury at some point in its history was stripped of its outer layers, either by a big collision with another body or by the erosive effects of being so close to the Sun. But the American probe observed large abundances of volatile substances. They shouldn't be there had those events happened in Mercury's past. The sulfur and potassium volatiles on the surface just shouldn't be there, insisted Professor Emma Bunce, a principal investigating scientist from Leicester University, UK. And the other mystery about the surface is that there isn't much iron on it, seemingly, and so that needs to be looked into in more detail. And that's something we'll be able to do with our imaging X-ray spectrometer, MIXS, Europe's MPO. We'll have a total of 11 instruments on board. It will fly in a near-circular polar orbit around the planet, mapping the terrain, generating height profiles, sensing the interior, and collecting data on surface composition and the wispy atmosphere. Japan's MMO will have 5 instruments and will investigate the planet's magnetic field. Mercury is the only terrestrial planet, apart from Earth, to have a global magnetic field. But it is an odd one. The field is roughly 3 times stronger in the northern hemisphere than it is in the south. Both ESA and JAXA are delighted to at last be approaching launch. The development of the mission, particularly on the European side, has been a toured learning curve. The launch date was repeatedly put back as engineers struggled to find equipment that could cope with the intense heat and radiation experienced just a few tens of millions of km from the sun. The development of solar cells in particular proved extremely problematic. "We're flying into a pizza oven," quipped the ESA project manager Ulrich Reininghaus. "We had to test materials at different, very high temperature regimes, sometimes with very unwanted results." When ESA's Science Program Committee originally greenlit Bepi Colombo in 2000, it had in mind a launch in 2009. Even when the industrial contract to build the MPO was finally signed in 2008, a launch was thought possible in 2013. ESA says the mission is costing roughly €1.65 billion, £1.45 billion, $1.85 billion. This includes all European and Japanese costs. One fascinating aside: that SPC meeting in 2000 also approved ESA participation in the successor space telescope to Hubble, which is called the James Webb Space Telescope. Its development schedule has also been heavily delayed and is itself now booked for launch on an Ariane in October 2018, but it is not possible to put both missions up at the same time, so one will have to stand aside. A decision on whether it is Bepi or JWST that goes first is likely to be made this September. Jonathan.Amos-internet@bbc.co.uk and follow me on Twitter @bcamos.